In this video, I'm going to be explaining all of the foot placement settings in the package. The first one is the layer field, which is the IK pass layer index. So the only one to be actually used and the rest to be ignored. And then the feet collision layer masks is the layer that the feet has to react to. And then the trigger behavior is how the feet has to behave with triggers. So we could set that to collide and it's going to take that like a collider. In the advanced physics cast settings, we have the first, which is the cast shape. And the first one is BoxCast and a SphereCast. It uses both, and whichever one gives the higher hit is the one used. Then the BoxCast, which is literally just a box. SphereCast, which is a server. And the Raycast, which is just the same line without any shape. Alright, so we'll select the original one so that we can see all of the settings because it's the most advanced one, so it has all of the settings. So the first one is the BoxCast size, which is the cast of the box size, and that should match your feet size when the foot is at 0 at the rotations. So I can make both the feet longer. If I make the right one as well, it's going to react to the slope because it starts colliding with it. So that's the BoxCast size field. And next one is these BoxCast offsets. Now this is actually a vector 2, and it does not allow you to go up and down. So it's constrained to 2 axes only. And the y-axis is actually the forward and backward offset, and the x-axis is the left and right offset for the cast. So you need to use these while the foot is flat to position correctly with the foot. So for this character, 0.06 is best. And then you have offset due to BoxCast multiplier, which is just a multiplier to keep the foot to the ground on slopes. Let me just bring him up here. And this is only for a BoxCast. So now if I make this a bit too high, nothing happens, but if I set this to 0, you can see that the feet are in the air. So setting it to 0.02 or anything greater than that is what gives us like a flat result. So that's that one. Then you have the SphereCast radius, which is that sphere casts radius just like the BoxCast size. That's all that is. Now let's have a look at the crouching behavior boolean. So that is basically going to control should we crouch or not, and how to behave with that. So when you're crouching, the body is going to follow the upper foot, not the lower one. And using this field, you can blend between the two. The crouching tolerance does that. Then you have force activate crouching behavior states. So this is going to enable the crouching behavior on its own when no script is touching it. But right now, because our state is the one only and everything is inside its blend trees, we can't use it. It requires a state name. Then we have force disable behavior state names. In your animations, if you have a jump start, you could use that. So we'll simply disable the IK, the jump start animation place. Then you have simple toggle to enable and disable the foot placement. And a show Gizmos toggle. And the feed IK weight, which controls how much should be applied. It's the global feed IK weight. The height from ground cast. So from the transform.y, how much above do we go before throwing out a cast? And then from the transform.y, how much down do we go? That's the cast down distance. As you'll see that. The feet position offset is the position offset on the y for all the feet. So we can change that like this. Usually you would keep the body position offset the same as the feet position offset to keep the animation looking the same. You have the max rotation angle, which is the maximum the foot can rotate on any angle. So you can see that that's about 18 degrees at the moment. 45 degrees I think makes sense. The auto calculate rotations is going to use curves if you disable it. This is not something you should do. You should just keep this on. Basically the rotations are added together to get the final rotation. The body IK weight, the body's IK weight, and the body position offset already explained. Ground check LayerMask is literally only the ground check LayerMask. The ground check distance is the offset from the transformer position for the ground check. And the ground check radius is the radius of both the ground checks. So now let's have a look at the slope leaning settings. When you increase the slope leaning amount, it's more like a multiplier. You can see that it's terribly increased. But we can control that by decreasing the maximum slope leaning, because that's the angle maximum the spine can lean. Keep that at 45 and set it to 0.1. Then we have the auto calculate velocity. So if your script does not want to provide the velocity using the set velocity function, it's called set calculated velocity inside the footplacer script. You can do that with a reference to it. Otherwise, you can enable this. It's going to automatically calculate it every frame. Use the previous position and the new position to calculate what the speed is. And the ignore velocity dependency is going to basically directly just use the slope itself instead of multiplying it with the velocity. And that's one. And keeping enabled actually will visualize how the shoulders, counteract, spine bending is actually working. So this thing, if we disable it, see the shoulders have gone there. If we enable it while there's no slope leaning, it's the same. But what it's doing is it's moving with the spines. Look at how it's running. It's like that. If you disable it, it's just like it's just childed to the spine and not really. So it gives a more physical look when you enable it. Then the slope leaning type, which is going to have 4 types. There are disabled, which is just not going to do any spine bending. The angle detected by feet, and the average angle detected by feet. The angle detected by ground check, or the height offset between the 2 feet. The height offset requires a multiplier because otherwise it's kind of uncontrollable, because it's not based on normals. It's instead the difference of the 2 feet. So something like maybe height offset multiplier to 100. But the thing about this one is it also reacts to stairs, while the ground check does that as well. But the average angle by feet does not, because the feet angle is not any much leaning on stairs. So you only get leaning with the average angle by feet on the slopes. Now the spine axis, basically, you can see this x-axis. It is set to the x-axis, and we can actually make that go in the other direction as well. To see this in effect, I think we need to disable the full body leaning. All it does is puts a negative in front of the final calculated rotation for the spine. And the y-axis would rotate on the y, because my character's y-axis is correctly set up. For other characters whose pivots are not good, you can change this, that's why. Next you have the full body leaning, which is basically the animator's body rotation, just modified. And it has similar settings, except it has a flip forward move lane only, which means it's going to go in the opposite direction. And the move lane is just like the spine bending, which has limits and the same amount body multiplier. So keep that just like that. Now let's talk about the footstep events. So the start step threshold is when the foot should start hitting the ground. That is when the feet reaches the Y height flat to the ground. So 0. And then start stop. Step stop is 0.07, meaning the foot needs to go up by that much to stop. And the min step length is the distance between the 2 feet before we can think of it as a step. The footstep delay is the delay before we fire off these events. Only the left foot start and the right foot start is affected. It's the delay for that only. And then you have left foot start event, the right foot start event, the left foot stop and the right foot stop. So in this case, the start and start have foot IQ results, which can be used because they have a struct passing in data. Actually a class, I think. So you could use ground enter, ground exit as well. So these are multiple events here that you can use. Then in the advanced settings, you can change the smooth damp settings for the feet. So bumping the speed up to 10, but then stairs would not look good. Or changing the foot smooth time. So we'll keep it back to what it was. And then the same for the foot rotation speed, which is just the rotation herb speed, and the body max speed, and the body smooth time settings, spine smooth speed, which is the speed at which the spine is set, using the lerp function again to make this really slow. And the last one is the crouching offset speed, which basically is this. So if you crouch, we can change the tolerance, right? So this is the speed that is being smoothed at. That's the actual place where this is used. So we can make this 1. I will see that's going to be really slow. And we could do anything with that. So the 1 speed is too slow, we keep it back to 50. Then for debugging and testing, you have key position offset calculations. Let's just talk about this one first, which is the show ground gizmos. This is just going to show it. Or the show SphereCast gizmos and the BoxCast and the ray gizmos. You can change each of them's color as well to whichever suits best. Now this key position boolean If you enable it, you'll see something in the left foot and right foot. Two empty game objects are created, one in the left foot and one in the right foot. So let's just enable that and hit play. So now is a left foot transform of set holder and a right foot transform. So what this script does is it does this to get the rotation of sets for both the feet automatically. So that's it for the tutorial, and I hope to see you in the next video. Subscribe, like, and get it right now.